So oxidation. Oxidation is addition of oxygen. Second thing, oxidation is removal of hydrogen. Up till now, as far as your AS syllabus is concerned, AS chemistry is concerned, you will have to memorize just these two definitions. So whenever any molecule that is going to add oxygen into it, it is called, it's doing its oxidation. Any molecule, if it is losing its hydrogen, it is said to be oxidation. So that is the general specific normal definition. Now the next thing is, what are the oxidizing agents that we are going to use? Oxidizing agents. There are basically only two oxidizing agents in AS chemistry as far as your syllabus is concerned basically. Number one, that is KMNO4, KMNO4 plus we will add acid into it, or you can add alkali as well, OH negative ion, plus we will heat under reflux. So one reagent is KMNO4, potassium magnate 7 oxide, and its original color is purple. Original color is purple. Whenever it reacts with, it oxidizes any molecule, its color become colorless. It change its purple color into colorless. Next reagent, what is the next reagent? That is K2Cr2O7. It is called potassium dichromate. Again, here I am going to tell you the condition. These are called conditions. These are called reagents. KMNO4, K2Cr2O7. These are oxidizing agent, as well as these are called reagents. These are called reagents. So these are reagents. These are oxidizing agent, yes. They are also said to be co-reactant. Co-reactant mean that is a second reactant. So KMNO4, potassium magnate plus acid, these are called conditions. These two are called condition. I mean acidic medium, water plus alkali, or water plus acid plus heat. These are called condition of reaction in organic chemistry. And this compound, this basically another reactant, co-reactant, is called reagent. It's called reagent. It is also said to be oxidizing agent. So the second reagent for oxidation is K2Cr2O7. It is said to be potassium dichromate, and again you need acid to help it out, or OH negative ion, that is also going to help this oxidation, plus again heat. You will write the word under reflux. I will let you know later on what is a reflux basically, and so on. So generally speaking, only these two reagents are used. What is the color of this potassium chromate? Its color is orange. It's orange in color, and it will change its color into green. It's change its color into green whenever it oxidizes the other substance. So basically, what are the oxidizing agent? There are only two oxidizing agent. One is KMNO4, other one is K2Cr2O7. One color is purple, its color is orange. When KMNO4 react with any oxidizing agent, it change its color, its own color, into colorless. And whenever K2Cr2O7 is allowed to react with any reagent and it oxidizes any reagent, then it will change its color green. Now the next step is, how many different functional group can be oxidized? How many different functional group can be oxidized in whole organic chemistry? In whole organic chemistry, we are basically going to talk about a unanimous organic chemistry. So number one, you can oxidize alcohol. You can oxidize alcohol. Oxidation. Oh, let me write it over here once again. You can do oxidation of alcohol, number one. Then you can oxidize aldehyde, aldehyde. Next thing is you can oxidize carbon-carbon double bond, I mean alkenes. You can oxidize alkenes. You can oxidize alcohol. You can oxidize aldehyde. That's all. That's all. There is no any further oxidation in your syllabus. So basically, you will remember there are only two reagents. One is KMnO4, other one is K2Cr2O7. Conditions are same. And yes, but here is a difference between these two. This one is said to be stronger oxidizing agent. Stronger oxidizing agent. OA mean oxidizing agent. And this one is relatively weaker oxidizing agent. KMnO4 is a stronger oxidizing agent and K2Cr2O7 is a weaker oxidizing agent. How? First of all, if I'm going to oxidize alcohol, then both can work. KMnO4 and K2Cr2O7 both can oxidize to the alcohol, I mean alcohols. Same is the case, these both can be used to oxidize aldehyde. And in the last one, only KMnO4 can be used to oxidize alkene. In this case, basically, the next one, that is K2Cr2O7, it cannot be used. So got it? That's why KMnO4 is going to be used everywhere in all cases. So KMnO4 is an oxidizing agent, relatively stronger oxidizing agent. K2Cr2O7 is specific for these two. It cannot oxidize carbon-carbon double bond. So this is the first step of this lecture. How many oxidizing agents are there? Can you repeat it, please? These can be oxidized. What are the oxidizing agent? Correct. Good. Cr2O7, potassium dichromate, and KMnO4 is known as, said to be called as potassium magnate. So yes, but only 3 compound can be oxidized. Whenever the question, the question is asking about the organic chemistry and oxidation, just 3 things come into your mind, that only 3 things can be oxidized. Alcohol can be oxidized, aldehyde can be oxidized, and alkene can be oxidized. None of the other functional group can be oxidized. Now I'm going to write the detail of these all, oxidation of alcohol, aldehyde, and ketones turn by turn. For example, first of all, I'm going to talk about alcohols. Alcohols may be primary alcohol. Alcohols may be secondary alcohol. Sorry. Alcohol may be tertiary alcohol. So primary alcohol can be oxidized into 2 compounds. Upon oxidation of primary alcohol, in stage number 1, it makes aldehyde. All primary alcohol on first stage, in first step, they are supposed to make aldehyde. If we are keep on moving, if we are heating under reflux, and if we are not going to perform distillation, we are doing reflux and there is no distillation, we are not going to distill off the liquids, we are not going to separate aldehyde out of the mixture, no distillation in case, then it will be changed into carboxylic acid. Finally it will be changed into carboxylic acid, right? So primary alcohols can be oxidized into two groups. This is step 1 oxidation, aldehyde. If you are doing oxidation again, then there will be the formation of carboxylic acid. So primary alcohol can be changed into two compounds. Secondary alcohol can be changed into only one compound, that is called ketone. And ketone cannot be further oxidized. So I'm going to mark the shortcut, but you are supposed to write the complete name. Oxidation of secondary alcohol will give ketone, and ketone will give no second step. That's final. Ketone cannot be oxidized. In case of tertiary alcohol, oxidation of tertiary alcohol is not feasible. Tertiary alcohol cannot be oxidized. But these things you will have to revise, you will have to, memorize and remember as well. What are the basic oxidation, what are the different reagent, which type of functional group can be oxidized. So at the moment we are going to talk about alcohols and aldehyde. First of all, for example, I'm going to write an alcohol that is said to be primary alcohol. This is the smallest primary alcohol in the universe. That is called methanol. So if I'm going to oxidize, so to balance the chemical equation, I will mark bracket, I will write O, I will close the bracket, and so on. At the top of the arrow, you can write KMnO4. KMnO4. At the bottom of the arrow, here I can write H positive ion, aqueous, plus heat. This oxygen is not the normal oxygen. It is said to be atomic oxygen. It is said to be nascent oxygen. This oxygen is basically given by these KMnO4. From where it comes? It comes from KMnO4. KMnO4 is losing oxygen to the molecule. KMnO4 is giving oxygen itself. So, it's going to make this KMnO4, the basic function of KMnO4 is to lose the oxygen to give the oxygen and so on. So here is this oxygen and you will write it into the bracket. So this is alcohol, it's a primary alcohol. And first of all, in first case, what should be formed and how it will be formed, I am going to tell you, and you will follow this route strictly. Number 1, there is a removal of 2 hydrogen. 2 hydrogens will be removed. 1 hydrogen from OH, other hydrogen from this carbon. It is having 3 hydrogen. Any one of hydrogen can be eliminated, can be lost. So, what is the remaining part? First of all, I have lost 2 hydrogen from here, 1 from oxygen, 1 from the immediate carbon, and from this, using this oxygen, 2 hydrogen and this 1 oxygen, there is a formation of water molecule. Now, what is the remaining part of the molecule? Alcohol's remaining part is this one. Am I right? Okay. Now, what is the next step? Next step is you will make this CO double bond. You will mark a double bond over here. Just follow my steps. So, this is the balanced equation and it is said to be aldehyde. It is said to be 1 carbon aldehyde, 1 carbon meth in all. Methanol is the name of this compound. Boom. The first step is completed. So, whenever you are going to oxidize, you will do the procedure like that, and you will remove OH hydrogen of OH group, and 1 hydrogen from the carbon. Now, here is the starting step 2, and so on. Step 2. If I'm again doing reflux, and then what will happen? Then let's see over here. If yet there is 1 hydrogen, this carbon is having at least 1 hydrogen, then the next step is possible. If this carbon is having no hydrogen, next step is not possible. It is having one hydrogen, it's having two hydrogen, then at least one of the hydrogen can be oxidized. How can we oxidize? I am going to change this H into OH. I am going to change this H into OH. So this is called oxidation. Again, I have added one more oxygen. I have introduced one more oxygen to this aldehyde. Now it has become methanoic acid. Methanoic acid. Methanoic acid, right? So this is the whole procedure. I mean, methanol is going to change first into aldehyde, and aldehyde, whenever you are going to oxidize any aldehyde, then this hydrogen of aldehyde, CH group, is going to change into COH group. We are going to introduce oxygen with the hydrogen in aldehyde. This is the shortest reaction, shortest oxidation of aldehyde into carboxylic acid. Every time aldehyde change into carboxylic acid. Every time aldehyde changes into carboxylic acid and so on. Now, come to the next one. Basically, I'm going to, now this time, I'm going to oxidize another alcohol. CH3, OH, and it is having H and CH3. What type of alcohol is this one? Primary alcohol or secondary alcohol? No, primary is having, if the carbon is alone, or the carbon is having only one carbon attached to it. Now, what about this carbon? Yes, it's a secondary carbon, and OH group is lying at the secondary carbon, so it is said to be secondary alcohol. Again, I am going to mark oxygen over here. I'm going to use oxygen over here. That is coming from K1O4 or K2Cr2O7. We will use acid. That is a symbolic representation of aqueous acid. Plus, you will write heat. These are called conditions. So, what is to be formed? What is supposed to be formed? How to oxidize this molecule? Let me know what I told you at the moment. This molecule can be oxidized. Yes, it can be oxidized. So, the step number one is, good boy. Which one? Yes, this one. Not this one. Not this one. The hydrogen of the same carbon atom. The carbon atom that is attached with OH group. So, what is the next step? First of all, and CH3, single bond O. Then what to do next? Good boy, double bond O. There is a carbon double bond O. What about next? Is there any possible step? Good boy. There's no hydrogen, so no next possible step is over. Shabash. Good. So this is the way. Basically, if you follow me strictly, if you follow me my scheme of studies, then hopefully, I hope, inshallah, you will get super duper in your organic chemistry especially. There are some specific things, some specific outline that you will have to follow to get accurate answer, getting the answer in shortest time interval. So basically, just try to follow me, just follow this mechanism, just follow this, memorize this sort of stuff, this sort of information and so on. Now, once again, this is the balanced chemical equation, but if you are going to write the balanced equation of this one, If he is saying that we are going to change alcohol, for example, CH3, CH2OH, and he is saying that you can write oxygen like that, and you will do the final oxidation. So final oxidation, once again you will have to recognize which one alcohol is this one. Is it a primary? Good. It's a primary carbon and it's a primary alcohol both. So primary alcohol will finally change into carboxylic acid. I am going to write a shortcut, but you will write the complete name. So how to make how to make the final compound? You will follow the same technique, same route. So how to, what to remove, what is removed basically. First of all, we are doing at our, you can say the rough page. On rough work, we are going to, I'm going to write it again, CH3. I am going to mark the displayed formula of this group, OH group. So only this carbon is under attack. Oxidation will happen on that carbon that is having OH group. Rest of the all carbon will remain unchanged, unaffected. So what to do? Please let me know. What is the step number 1? 2 hydrogens, correct. This is step number 1. C double bond O. There is 1 hydrogen. Is there any possible step 2? Good. So I will change it into OH. Right, good. This is the final. So I'm going to write it over here. Okay, can we balance this chemical equation? Is there anything missing? Do you think, should we write any other thing to make it balance, any other substance? Basically, we will write H2O. Whenever you are going to remove hydrogens, these 2 hydrogen will change itself into water. Can you see now properly? Okay, so to balance this chemical equation, we will have to mark 2 over here. Now this is the balanced equation. Carbons are balanced, hydrogens are balanced, oxygens are balanced. Got it? And now the last one for today especially, I'm going to write an alcohol. Will you let me know what type of alcohol is this one? Tertiary. And this cannot be oxidized. However, correct, because this is having no hydrogen. So at least 1 hydrogen should be there, because the first step is to remove 2 hydrogen, not 1, 2. In first step, we will remove 2 hydrogens. Then we introduce oxygen if there is yet hydrogen left. So this is the shortcut way to do oxidation. Now we will discuss this oxidation of alkene later on, hopefully tomorrow inshallah. But you will revise this oxidation of alcohol and oxidation of aldehyde. So we have completed the 2 component. This is aldehyde. So I told you about the oxidation of 2 functional group, aldehyde and alcohol. So aldehyde and alcohol. Aldehyde just changes itself into acid. Alcohol can be changed into basically 3 compounds. Number 1, it can change into aldehyde, it can change into carboxylic acid further, or if it is a secondary alcohol, then it can be changed into ketone. So in this way, in this style, you are going to think that alcohol can be changed into acid, ketone, aldehyde. Or you can also think in a reverse way that aldehyde can be made from alcohol, acid can be made from primary alcohol, ketone can be made from secondary alcohol. So if you are going to have this all sort of stuff, if you are thinking all the way around about these reaction, so your chemistry, organic chemistry, then you can get full marks. It will be very good. That's all for today.